Manju? Manju? Nandini இருக்கீங்களா?
Ma'am.
மஞ்சு நேத்து நீங்க அட்டெண்ட் பண்ணல. ஹலோ
ஹலோ.
மஞ்சு உங்களுக்கு நெட்வொர்க்லாம் கரெக்டா கிடைக்குதாப்பா?
கேக்குது மேம்.
கேக்குதுங்களா? ஏன்னா உங்களுக்கு சைடுல ப்ராப்ளம் இருந்துட்டே இருந்தது இல்லைங்களா?
ஆமாம்மா, லாஸ்ட் கிளாஸ் அப்படிதான் இருந்துச்சு. நேத்து ஊருக்கு போயிருந்தோம் பொங்கலுக்கு.
சரிப்பா சரிப்பா. ரெக்கார்டட் வீடியோ பாத்துக்கோங்க.
சரிங்கம்மா.
ஓகேவா? ஓகேப்பா.
ஓகே.
ஓகே, நேத்து என்ன எடுத்தேன் அப்படின்னா ஆட்டோ டிரான்ஸ்ஃபார்மர் எடுத்தேன். ஓகேவா? So auto transformer is nothing but the two winding will be taken as a single winding. It will act as primary as well as secondary. So in that case we can take with respect to tappings. So we are taking the tappings. With respect to tappings, the primary and secondary will be considered. Okay, wherever we are taking, accordingly we can take that will be primary. So this upper part, the entire part will be taken as a one winding, and in the tapping, wherever we are taking the tapping, based on that we can take that will be the secondary. From here we are connecting the load. If suppose if we are taking that will be I1 will be the current, I2 will be given to the load, means the remaining current here will be I1 minus I2. So that has been split into two. So one will be I1 to up to this winding and I2 to the load, and the remaining turns which has the current of I1 minus I2. Okay, so this one we had seen yesterday's class, and in that we have taken that will be saving of copper in that ordinary winding as well as auto transformer. Okay, saving of copper. So that will be, we can take W naught minus WA we are taken. So with that we are taking the relation 1 minus K into input, we are taken the relation. And also if that will be conducted, Manju, can you tell what we have seen in the last class? The power transfer, if it is conductively. So what is that saving of copper? That is K into input, isn't it? Inductively, we can take 1 minus K into input. Is it correct? Nandini?
Yes, ma'am.
Irkingla?
Yes, ma'am.
Okay, based on that, we have seen the problem also. So now today we will see that will be conversion of two winding transformer into auto transformer, and the parallel connection of the transformer. And in the parallel connection, what are the conditions to be consider. Okay. So in the conversion of two winding transformer, so we have to take normal ordinary transformer. Conversion of two winding transformer into auto transformer. Board theriyudappa? Full view theriyudilla? Okay. So normal two winding transformer we will take. So primary winding the voltage will be, we can take that will be 2400 and secondary will be 240. So that is step down transformer. So we have to take that number of turns will be less number of turns. Okay. So the same will be converted into single winding. So in the case we have to take that output, we are taking that will be phase from that phase of the primary, we are taking the output terminal, and secondary will be connected to the neutral of phase of the secondary will be connected to the neutral of the secondary, and from primary phase and secondary neutral we are taking that output. Okay, so that winding will be seriously connected, so we can get single phase winding. That will be, we are taking that primary winding phase and neutral will be neutral of the secondary, and primary phase will be taken as the output. So the winding will be connected in series. So in the case if it is the polarities are additive, we can get that will be step up transformer. If it is subtractive, we can get that will be step down transformer. So if in the case we can take that will be primary winding as well as secondary winding, this will be the rating of the voltage will be 2400 and so that will be 240. So if in the case we are taking that will be how that to be added, so that will be connected in seriously. So we can get that will be the resultant will be, we can take that 2400, sorry, 2640. Okay, so the common terminals, we are taking the common terminals at the top. Okay, so or otherwise we can take the common terminals at the bottom also we can take. So if in the case we are taking that will be, so here the common terminals at the top means we are taking that will be primary at the top, or otherwise we can take the primary will be at the bottom also we can take. Okay, so if in the case the secondary voltage will be 240, so in that will be connected to the load. Again that whole the winding, that voltage will be added, so we can get that step up transformer we can get, that will be 2640 we can get. So if in the case of opposite polarity, that will be subtractive. So in the case additive polarities means either we can take that will be primary in the top or at the bottom, the polarities are added and we can get that will be increased voltage at the output. If we want to get that will be step down transformer, the polarity will be reversed. So the same connections we can consider. So if in the case, so here the main connection will be, so in that phase of the primary as well as phase of the secondary will be taken as the output. So this voltage will be 2400 and this will be 240. So in that we are taking that will be opposite polarity. So here we are taking that will be positive, that is phase of the primary as well as phase of the secondary will be, we can consider. So in that that both will be at the bottom, both are connected together. So in that we can get that will be subtraction of these two voltage. So we can get 2160. So that can be taken the primary at the top or bottom. So if in the case we are taking that will be, so this will be phase neutral and again this will be phase neutral. If you are taking, if in the case we are getting that will be subtractive polarity, we can get 2160. Similarly, the primary will be at the bottom also, we can get that will be phase. So in the case that will be neutral, or this will be phase and neutral. So if in the case we are getting that will be subtractive polarity, that is step down transformer. So depends upon the polarity, we can increase the voltage or decrease the voltage. So we can take that will be either step up or step down also. Okay. So the single winding, we can convert it to two-phase winding will be into single winding, that is auto transformer winding. So if in the case we can add the polarity or subtract the voltage, depends upon the connections of the polarity. Okay. So with that we can see one of the problem based on that. So in that what is the transformer, the two winding transformer rating, how that will be converted into single, that is auto transformer winding rating also. Take down for 20 kVA, for 20 kVA 2400 240 voltage, two winding step down transformer, two winding step down transformer, connected as an auto transformer, connected as an auto transformer with additive polarity, with additive polarity. Compute original current capacity of high voltage winding, compute original current capacity at high voltage side, second, and original current capacity at low voltage side. Next, kVA rating of auto transformer, okay, and what value of I1 and value of I2. The value of I1 and current in secondary winding and value of I2. So these are after converted. So first we are computing that high voltage side current, low voltage side current, then converted into kVA rating of auto transformer. Then in that auto transformer we have to compute the value of I1 and the value of I2 and the current in the secondary. That is the current which is we can consider that will be, this will be additive polarity. How that will be, we can take that will be either at the bottom or at the top. So in the case we can consider, so what about this current? If you are taking that will be auto transformer, so that is the current, we can take I1 and this will be I2. Okay, so this will be 2400 and the voltage across will be, voltage across this will be 240. The current is I1 and this will be the current I1 and this will be current I2. What about this current? Can you tell? So this will be I1 minus I2. Okay. So I1 minus I2 because So as per the KCL law, so entering current will be positive, leaving current will be negative. So I1 will be entering, leaving will be I2. So this current will be I1 minus I2. So this can be, we can take the current in secondary. So that can be represented as common current. Okay, so common winding. Okay, so can you tell how we can calculate high voltage side current? So that is in two winding transformer. Okay, in the two winding transformer, how we can calculate the current? Actually, what is the power? P is equal to V into I. Okay, so P is given 20 kVA, 20 into 10 power 3. So V is given. So the primary voltage, high voltage side here will be 2400. That is the primary. Low voltage side will be that is secondary 240 voltage. Okay. Just a minute. Okay, Lakshmi join பண்ணிட்டீங்களா? போர்ட்ல கிளியரா தெரியுதா? Lakshmi?
Yes, ma'am.
எல்லாமே கிளியரா இருக்காப்பா? ஆடியோ, வீடியோ எல்லாமே கிளியரா இருக்கா?
Clear இருக்கு ma'am.
உங்க வாய்ஸ் பிரேக் ஆகுதுப்பா, பாருங்க. இப்போ high voltage side voltage வந்து நமக்கு what is the high voltage side voltage 2400 into current we can represent I1. Okay, so this is two winding transformer. So that is two winding transformer. Okay, so in the case you have to calculate I1 equal to, that is two winding transformer. So we can take P divided by V, that is 20 into 10 power 3 divided by 2400. Can you tell what is the answer?
$8.33, ma'am.
Okay, 8.33. Similarly, that is, this is high voltage side. So low voltage side, second one is low voltage side. That current will be, we can represent I2 in the two winding transformer. Similarly, P divided by V2. So this will be V1. So P is 20 into 10 power 3. V2 is nothing but 240. How much for? So
83.33, ma'am.
Yes, 83.3. Anyone, can you tell I2 we can directly calculate with the help of other relation, that is turns ratio relation. So K is equal to I1 divided by I2, no? So I2 is equal to I1 divided by K. Like that also we can calculate. So K is equal to nothing but V2 by V1. So V2 is 240, V1 is 2400. தெரியுதாப்பா உங்களுக்கு?
Yes, ma'am.
2400. So 1 by 10. Okay, so I1 will be 8.33 divided by 1 by 10, or otherwise 8.33 into 10. So we can get 83.3 amps. Okay. Next, third one, KVA rating of auto transformer. So how we can identify KVA rating? What is KVA rating? That is nothing but voltage into current. Why the transformer rating will be in terms of KVA? Already I told. The core loss depends upon voltage and copper loss depends on current. So none of the power factor will be included. So independent of power factor. So the transformer rating will be in terms of KVA. Okay, transformer rating will be in terms of KVA. So KVA rating of auto transformer. So this will be additive. Auto transformer polarity will be additive. Okay, additive means the primary will be, we are getting that will be, what is that? Primary will be 2400. So after converted into auto transformer, how the connections will be? So primary will be 2400 and secondary will be, we can take at the top or at the bottom. So if in the case, if you are taking at the top 2400 and secondary winding, the voltage will be 240. So we are connecting the load. Where we have to connect the load? So across the secondary. Okay. Or otherwise, if you are taking at the bottom also, we can take, if it is additive polarity, what about the terminal voltage across the secondary? If it is additive polarity, what about the terminal voltage across the secondary? So we had seen no 2400 and 240 that across the secondary, that is across the load, that is V2. What about V2? If it is additive polarities means both the primary voltage and secondary voltage are added. Okay, so we can get 2640, isn't it? 2640, that is V2. V2 equal to 2640 because of additive polarity. Okay. So now I2 we calculated. What is I2? That will be the current, same current. So I1. So here I1, I2, this current will be I1 minus I2, the common terms which has the current of I1 minus I2. So in that case, so what is V2? 2640. What about I2? We calculated 83.3 amps. So KVA rating of auto transformer will be V2 into I2. Okay, V2 is 2640. I2 will be 83.3. That is the rating of auto transformer. What is the value? Nandini, Manju,
Wait, ma'am.
Ma'am, 2,19,912.
so 2640 into 83.3.
219912, ma'am.
219
2199.
9912 12.
Okay, so we can take that will be 219.912 kVA. Can we write like that? So 219912, can we write like this? So 219.912 kVA in terms of kVA. So this will be VA. Okay, so you have to convert that will be into kVA means, so 219.912. So that will be divided by 1000 now, isn't it?
Yes, ma'am.
Okay, so this will be kVA rating of auto transformer. So similarly, nearly we can write approximately 220 kVA. What about that will be ordinary transformer kVA? Given 20 kVA. Okay. So from that we can identify what is the percentage. That percentage of increasing kVA. So auto transformer kVA divided by ordinary transformer, two winding transformer kVA. So that is nothing but 220 divided by 20 kVA into 100. So what will be the percentage? How much percentage increases in the auto transformer?
11%.
11,000. Isn't it?
Yes, ma'am.
11,000 percentage. That will be increased. The kVA rating will be increased. That will be this much percentage that has been increased. Okay. So now, next one that has been I1 is asked. In the auto transformer, I1 will be asked. So what is the kVA rating of auto transformer? So I1 after converter the two winding transformer into auto transformer. Okay, so this will be 2400 and this will be 240. Okay. So this will be converted into this. This rating will be 220 kVA. This rating will be 220 kVA. Now what about current in that auto transformer I1? How we can calculate? Manju? Same. P is equal to V1 into I1.
I1.
So P is here new conversion. The rating will be 220 kVA.
220
10
equal to
power 3.
equal to
V1 will be 2400. The same only. I1. So I1 equal to previously 20 kVA we have taken. Now we have to take 220 kVA. I1 equal to 220 into 10 power 3 divided by 2400. How much more? மஞ்சு உங்களுக்கு டிஸ்கனெக்ட் ஆயிடுச்சாப்பா நடுவுல?
இல்ல மேம் கை டச் ஆயிடுச்சு மேம் தெரியாம.
சரிப்பா.
ஹேண்ட் டச் ஆயிடுச்சு.
$91.66, ma'am.
Okay, 91.66. So we can write 91.7 also we can take. Okay. Then what about the common current? That is IC. All that will be supply current is I1. So this will be the common term. Current will be I1 minus I2.
I2.
I2 already we calculated 83.3. Or otherwise you can calculate 220 kVA divided by 240. Check with that 83.3 you are getting or not. Already we calculated the same only the I2. So I1 will be changed because of rating, kVA rating that has been changed. Are we getting 83.3? Or raise tell how much you are getting.
916.66, ma'am.
916.66. So I2 is not necessarily calculated. Already we calculated no I2 after converted that is which one? Auto transformer, that I2 will be the current which will not be changed. Okay, so I1 will be changed because of rating, because input power rating will be 220 kV is given. So in that I2 will be the current which is to the load. That load current already we calculated, isn't it? So in the case that common turn winding current will be I1 minus
Yes,
I2
ma'am.
91.7 minus
0.7 minus
83.3.
8.4, ma'am.
8.4. Okay. So now,
8.4.
yes, now you have to add in the problem, compute percentage overload of 2400 winding. Compute percentage overload of 2400 winding. That is primary winding. So in the previously primary winding, that is, so now what is the current we are getting? 8.4, isn't it? And the percentage overload of 2400 winding is nothing but we can identify that will be I2 divided, that is here, that is common current divided by I2. So the common current that is nothing but the primary current after converted into auto transformer primary current. Okay, divided by I2. I1 divided by I2. I1 is primary current is 8.4 and I2 will be 83.3 into 100. How much, ma'am?
$10.08
Into 100.
percentage, ma'am. 10.08%.
Into 100 also.
Photo-
Yes, ma'am.
10.08 or 100.08?
10
Ma'am?
வருது.
Yes, ma'am.
10.08. 10.08, ma'am.
Okay. So the percentage overload in the primary after converted into from two winding to single winding, we are getting that load percentage overload will be 10% that has been overloaded. Okay, the single winding will be taken for primary as well as secondary winding. So in the previous case, double winding we have taken, that has been converted into single winding, means that primary winding gets overloaded this much percentage of comparatively the two winding. Okay, so now we can see about it will be parallel connection of transformers, two winding transformer. So in the parallel connection, we have to take the primary and secondary of, we have to take the two transformers in this case. So the two transformers should be connected parallel. Okay. So here we have to take the primary to primary will be connected. Sorry, is that face to face of the two winding will be the second transformer to be connected. Similarly, neutral will be connected. Okay. The primary winding of first transformer will be connected to the face of the primary winding, connected to the face. Neutral will be connected to neutral. Similarly, in the secondary winding, face as well as neutral will be connected. Okay. So in that we have to give that will be for primary as well as for secondary. So we have to give to the bus bars the voltage size. So we can take that will be primary bus bar, and this will be secondary bus bar. Board clear irukappa? Secondary bus bar. So these two will be interconnected, primary to primary as well as secondary secondary. So what are the conditions? So in that when we are connecting the two transformer is in parallel, so we have to take the identical transformer. That is, both the rating of the transformer will be same. So primary winding of transformer is suitable to connected with the supply voltage. Okay, first condition will be, so primary winding will be suited for connected with the supply voltage. So for that we have to take a two identical transformer, and polarity will be properly connected. So polarity should be connected properly. That means primary of primary, both the primary will be connected as well as both the secondary of phase and neutral will be connected with the proper polarity. Connected properly. That is, should be identical transformer. What is the meaning of identical transformer? The rating of transformer will be same. For example, this will be 20 kVA rating, means this also 20 kVA only. That at that time only we can connect the two transformer is in parallel. Okay. Next, the percentage impedance. Fourth will be the percentage impedance will be in equal magnitude. The percentage impedance in equal magnitude. Okay. So what is that impedance? How we can calculate? Is it equal to V by I? So if in the case of Z01, also we can take Z01 equal to V1 by I1, or Z02 is equal to V2 by I2. Okay, so Z01, Z02 will be nothing but equivalent resistance or equivalent impedance referred to primary as well as secondary. So if in the case we can calculate, if you know Z01, how we can calculate Z02? How we can transfer from primary to secondary side? Can you tell anyone? Nandini?
Ma'am.
So Z01 will be to secondary side. Transfer to secondary side. If in the case, how it will be transfer? If you know Z01, that is primary equivalent impedance. Okay. So that to be transferred to secondary side. So Z02. So while transferring from primary to secondary, what to be done? Multiply by K square. Isn't it?
Yes, ma'am.
From Z02 to Z01 means divided by
K square.
Okay, so what about voltage from secondary to primary? V2 dash. Manju? இதெல்லாம் திரும்ப திரும்ப சொல்றது ஏன்னா டக்குன்னு நம்மளுக்கு வந்து ஸ்ட்ரைக் அவுட் ஆகணும். So V2 and I2. So current and voltage not by turns ratio square, turns
V2
ratio 1.
K.
V2 by K.
K.
Similarly, I2
Into
dash equal to K into
into
I2.
K.
Okay. Okay, next will be three-phase transformer. Okay, in the case of three-phase transformer, so already we know where we are using the three-phase transformer. So generally the power will be generated at the generating station. Okay, power will be generated. So in the case of generating station, we are taking that will be AC generator. That is nothing but alternator we are taking. At generating station, we are taking that alternator. The voltage will be, the power will be generated. The same power will not be transmitted because of drop occurs in the transmission line. Okay, so drop occurs in the transmission line. So we could not transfer the same power how that has been generated. So that we have to increase the power, that is increase the voltage with the help of step up transformer. Okay, and that will be transmitted through the transmission line. Okay, so at the distribution station, so what we are doing again, that same, that voltage which has been increased will be decreased to our requirement. So what about our requirement? If it is industries means we can use, that will be 440 voltage. If it is home appliances or lighting loads means we can use, that will be 230 voltage is enough. So after transmitted, that will be distributed. So at the distributing station, we can get, that will be step down voltage. The voltage will be decreased with the help of step down transformer. Okay, during transmission or after the power will be transmitted with the help of step up transformer and distributed with the help of step down transformer, the same voltage will not be transmitted because drop which will occur in the transmission line due to resistance and reactance. So if we are transmitting the same power at the receiving side, we will get the reduced amount of voltage due to losses, so that we are increasing the voltage, same that will be decreased at the distribution station. Okay, from that generally we are generating the voltage that will be 130 kV or 232 or 66 kV. We are generating the 11 kV. Okay, in that order we can generate. The same will be in the distribution station. So the same will be, so 11 bar 132 kV means that 11 kV will be generated, that has been increased to 232 or 132 kV due with the help of step up transformer. Again the same voltage to be get. Okay, so that we have to take that 11 kV will be at the distribution side. Okay, in the case we are using, that will be 3-phase transformer will be taken. Okay, in the 3-phase transformer we have to take the transformer connection. What about the transformer, 3-phase transformer connection or 3-phase connection, how we can take? So here we are having, that will be 3 windings, that is 3 transformer. We have to connect, that will be either in terms of star connection or in terms of delta connection. Okay, whenever we are taking the 3-phase transformer, we have to take either in star connection or
Star delta.
delta connection. Okay, so can you tell at the time of transmission we can take, that will be delta connection. At the time of distribution we can take, that will be star connection. That will be 3-phase 4-way system. We can
Primary.
say 4-way system, and this will be 3-phase 3-way system. Okay. So what is the relation we can exist in the star connection as well as delta connection? So we can take, that will be commonly, we can take that connection will be star to star, that will be economical. So due to economical purpose, we are taking, that will be star to star. That is
Line
so
voltage, ma'am.
Yes, ma'am.
Star to star வந்து line voltage.
Yes, line voltage. Okay. இது வந்து நம்ம generating station as well as distribution stationல we can take star to star connection for economical purpose, or otherwise we can take, that will be star to delta or delta to star also we can consider. Okay, so in that star to delta connection, so this will be needed at substation transmission line. Okay, substation transmission line we are taking. Okay, and so voltage will be where the voltage will be step down. Okay, there we can use. Okay, the primary will be star and secondary will be delta. So line between star to delta, the line voltage will be, phase difference between star to delta connection line voltage will be 30 degree. Okay, so if you are seeing the circuit theory, I hope. So if you are taking, that will be 3-phase system. So in the connection, we are taking star and delta connection. And also the phasor diagram also we can represent. Okay, if it is phase means so IRN and 120 degree, that is VRN and VYN, similarly VBN, isn't it? And that if you are extending this one, that VYN is nothing but phase, RN is also phase. If you are extending, this will be minus VYN. So if we want to find the resultant, we are getting that will be VRY, that is nothing but line voltage. So by taking the phase voltage in the phasor representation, we can find the resultant in terms of line voltage. Okay. So similarly, star to delta connection will be taken in the substation transmission line, as well as where the step down voltage is necessary. The primary and secondary also, that will be the line voltage between star and delta connection will be 30 degree. Okay. Next, delta to star. So delta to star, that will be reverse wise. The between the delta to star line voltage is also 30 degree, and where step up transformer, that is where the voltage will be increased. Voltage is increased there. If you want to increase the voltage, step up the voltage, there we can use. Okay, the previous case we have taken that will be for step down the voltage. So here where that will be high tension transmission system is required, there also we can use. So high tension means, so we can use that will be HVDC, high voltage direct current. So in the case also we can use that will be delta to star connection is used where the voltage will be step up, and also high tension transmission line also. And also we can use this will be lighting circuits. Okay. Now you have to tell, so the star to star connection, in the case of star to star connection, where that will be needed the small high voltage transmission. The voltage will be smaller value of high voltage to be transmitted means, in the case we can use star to star. Otherwise, step down means star to delta. Step up means we can use delta to star. Okay. So can you tell what is the relation exists in the star connection as well as delta connection? What is the star connection? So star connection means if you are taking that will be positive and negative of one winding means all the negative winding, the terminal will be connected together at one point, isn't it? So this will be, suppose if you are taking this will be as a reference, angle will be 0, this will be minus 120, this will be minus 240 or plus 120. Okay, similarly in the delta connection. So what is the delta connection? The positive terminal, negative terminal of first winding will be connected to the positive of the second. Negative of the second winding will be connected to the positive of the third. Okay, we can get the closed loop. If you are taking this will be as a reference, 0 angle will be the 0 and minus 120 degree, or that will be plus 120 degree or minus 240 degree. Okay, so what is the relation exists in the star connection? If you are giving the supply, three-phase supply means, okay, so the line voltage will be √3 times of phase voltage. Okay, line current. So if you are taking this will be, for example, RYB. So the line current will be the current through the line. So the same current will be flowing through the phase also. So the line current equal to phase current. Similarly, here delta connection. If you are taking the three-phase line, okay. So between the two lines, the voltage between two lines is the line voltage. Between the two lines, what is there? Phase is there. Okay. So that we can say that line voltage equal to phase voltage and line current is equal to √3 times of phase current. So you have to remember one of the windings. So one type of connection, then you can take that will be reverse of that. If you are taking that will be delta connection, you can easily identify that will be between the two lines. The line voltage between the two lines will be line voltage. Between the two lines, we are having one phase. Okay. So the phase voltage and line voltage will be equal. The current will be, line current will be √3 times of phase current. Okay, that will be reverse wise in the star connection. The line voltage will be root 3 times of phase voltage. Line current will be equal to phase current. Okay. So we have to identify the three-phase transformer. The three-phase transformer, in the three-phase transformer, we can take that will be two legs. That is the meaning we can take the winding will be present here, and we can take that will be two legs or three legs also. So three legs means we can connect each leg. We can connect the winding. Okay. And also it may be extended up to 5 legs also. Okay, up to 5 legs that can be extended. Okay, with the help of three-phase transformer, you can see one of the problem in this, and I will complete this one, the transformer topic, and next class onwards I will take the generator and motor. I hope that you are having that notes for the generator and motor, isn't it?
Yes, ma'am.
Yes, for மோட்டார் ஜெனரேட்டருக்கு நோட்ஸ் வச்சிருக்கீங்க போல இருக்கு. சார் அனுப்பிச்சிட்டு இருக்காருன்னு நினைக்கிறேன். Take a three-phase transformer. Three-phase 58 transformer as a delta connection. A three-phase 58 transformer as a delta connection with the voltage of with the voltage of 440. So in the other connections also there, that will be V2V open delta or V2V connection and spot connection, like that. So I will tell what is the types of connections in that three-phase transformer. Okay. So a three-phase 50S transformer has a delta connection, voltage of 440, primary and secondary. Primary and secondary, the line voltages are 22,000 volts and 440. The secondary has star connected balance load at 0.8 power factor lagging. The line current on primary is 5 amps. Determine the current in each coil of primary and each secondary line. What is the output of transformer in kilowatts? What is the output of transformer in kilowatts? So delta connected primary and star connected secondary. Okay. So delta connected primary and star connected secondary. So across secondary, the line voltage will be, What is it? We are getting 440. Isn't it? Across the primary, the voltage will be 22,000. So given voltage, if it is not specified, simply it is here, it is given line to line voltage is given, but it is not specified also the given voltage is line voltage only. Okay. So and also the current in the primary side will be 5 amps. Okay. And what about that primary voltage? That is primary voltage will be 22,000 and this will be actually this will be delta connection. So this line voltage will be in primary side line voltage will be 22,000 that is equivalent to phase voltage, isn't it? Line voltage and phase voltage are equal. So between the two lines voltage is line voltage. Between the two lines one phase is there, that is the phase voltage. Similarly in secondary side, what about that will be? Line voltage will be 440, that is star connection. So what about phase voltage? Line voltage equal to √3 times of phase voltage, isn't it? So the phase voltage is equal to VL by √3. Okay? Is correct? So phase voltage in the primary side will be, primary phase voltage will be 22,000. Secondary phase voltage will be equal to 440 by √3. How much more?
254.04.
254.
04.
Okay. Okay. So now, what about the phase current in the primary side? Primary phase current. Anyone? What is the line current? Actually, 5 amps. So in delta connection, line current equal to √3 times of phase current. So phase current equal to IL by √3. So 5 by √3. ஒன்னும் இல்லப்பா, அந்த ரிலேஷனே யூஸ் பண்ண வேண்டியதுதான், அவ்வளவுதான்.
2.88, ma'am.
2.88. Okay. Now the secondary phase current is nothing but primary phase current, and we have to identify that what is that turns ratio. Turns ratio K. Manju, turns ratio K எப்படி calculate பண்ணலாம்ப்பா? So secondary voltage by primary voltage. Secondary voltage என்னப்பா?
440.
440. அதுமே லைன் வோல்டேஜ் தான். பிரைமரி வோல்டேஜும் பிரைமரி சைடும் லைன் வோல்டேஜ் தான் 22,000. சரிங்களா? எவ்வளோப்பா?
0.02, ma'am.
0.02. Okay. So that secondary current, secondary phase current equal to secondary phase current in 3-phase transformer. Okay. So primary phase current plus K by √3. So So primary phase current எவ்வளவுப்பா 2.88 கரெக்டா 5/√3 sorry that will be so secondary phase current will be primary phase current divided by that k/√3 primary phase current divided by k/√3 so primary phase current will be 2.88 k value will be 0.22 divided by √3 so we are taking that will be what is it will be the ratio I1 by I2 equal to k1 கரெக்டாப்பா இந்த ரேஷியோ தான் so I1 by I2 equal to k1 in terms of current the turns ratio will be I1 by I2 அதே மாதிரி secondary phase current will be I2 will be equal to I1 by 2 so you can take I1 by 2 சரியா so I1 by k sorry I1 by k so the I1 by k will be also taken in terms of phase value so clear இருக்கா so நம்ம இருக்கிற ஜெனரலா இருக்கிற அந்த ரிலேஷன் தான் யூஸ் பண்றோம் so நம்மளுக்கு பிரைமரி சைடுல டெல்டா கனெக்ஷன் செகண்டரி சைடுல ஸ்டார் கனெக்ஷன் டெல்டானா லைன் வோல்டேஜ் phase voltage equal starல line voltage equal to √3 times of phase voltage so we can find out the phase voltage similarly line current in the primary la வந்து √3 times of phase current so அதுல வந்து phase current we have to calculate secondary side la line current equal to நமக்கு என்ன நமக்கு secondary side current we can calculate from the relation I1 by I2 equal to k so that the k will be also taken in terms of phase so that I2 equal to I1 by k okay k will be taken that will be by √3 okay in terms of phase we have to identify so what is the value for 2.88 by 0.22 by √3
249.4 ma'am
249.4
4
2.88 into √3 by 0.22 correct
ma'am 0.02 ma'am 0.22 இருக்கு
0.02 sorry 0.02 by √3 அப்ப 2.88 into √3 by 0.02 correct
yes ma'am
சரி next what is the output என்னப்பா ஆக்சுவலா இது என்ன கரண்ட் நமக்கு இங்க வந்திருக்கிறது I2 ல வந்திருக்க கரண்ட் என்ன கரண்ட் k/√3 போட்டுருக்கோம்ல அப்ப என்ன கரண்ட் நமக்கு ஆக்சுவலி
phase current
okay
phase
phase current வந்து நம்ம செகண்டரி சைடுல phase voltage கால்குலேட் பண்ணிருக்கோம் அப்ப லைன் கரண்ட்டும் phase கரண்ட்டும் ஈக்குவலா நமக்கு செகண்டரியில ஸ்டார் கனெக்ஷன்ல லைன் அண்ட் phase ஈக்குவல் அப்ப வந்திருக்க கரண்ட் நமக்கு phase current ஈக்குவல் டு லைன் கரண்ட் ஓகேவா கரெக்டாப்பா
yes ma'am
phase current to line current to same in that star connection delta connectionல phase voltage line voltage equal சரிங்களா இப்ப output power என்ன what is the equation for output power what is the output of the transformer in kilowatts னு கொடுத்திருக்காங்க அதுக்கு முன்னாடி So that secondary has star connected balance load at 0.8 power factor lagging. Okay va? So in three phase la power in three phase power equal to, so general power V phase, I phase, cos phi. Three phase la 3 into V phase, I phase, cos phi. Correct ah? இப்ப V phase star la எடுத்துட்டோம் அப்படின்னா V phase வந்து நமக்கு என்ன √3 times of V phase என்னப்பா ஸ்டார்ல VL equal to √3 times of V phase ஆ. அப்ப V phase equal to
VL by 3.
VL by √3. Substitute பண்ணீங்கன்னா 3 into VL by √3. So starல I phase உம் IL உம் same. Then into cos phi. So 3 you have to take in terms of √3 into √3. √3 into √3. So VL IL cos phi divided by √3. So we can get √3 VL IL cos phi. Okay va? அப்ப VL என்னப்பா செகண்டரி சைடுல VL என்ன √3 VL equal to கால்குலேட் பண்ணிருக்கோம் என்னது (440) லைன் வோல்டேஜ். செகண்டரி சைடு வந்து ஸ்டார் கனெக்ஷன் பா. ஸ்டார் கனெக்ஷன்ல கொடுத்திருக்கிற வோல்டேஜ் லைன் வோல்டேஜ் 440. ஸ்டார்ல வந்து லைன் வோல்டேஜ் ஈக்குவல் டு √3 டைம்ஸ் ஆஃப் ஃபேஸ் வோல்டேஜ் வேணும்னா தான் நம்ம வந்து கன்வெர்ட் பண்ணதை எடுத்துக்கணும். கொடுத்திருக்கிறதே 440 லைன் வோல்டேஜ் தான். சரியா? And the current we calculated line current, that is phase current we calculated, that is equal to line current 249.4 into cos phi எவ்வளவு கொடுத்திருக்காங்கப்பா 0.8. சரியா நந்தினி?
Yes ma'am.
கரெக்ட்டா கொடுத்திருக்காங்க. செகண்டரி சைடுல பேலன்ஸ் லோட் at 0.8 பவர் ஃபேக்டர் லாகிங் கொடுத்திருக்காங்க. Secondary side is star connection. So star connection la line voltage is given. So phase current we calculated, that should be equal to line current. So output power equal to 3 V phase I phase cos phi or √3 VL IL cos phi. Either in star or in delta. Okay. So what is the value? எவ்வளவுப்பா? நந்தினி
152.05 kilovolt.
152.05 kilowatts. Okay, kilowatts. Okay va? Okay. So wind up பண்ணிக்கலாமாப்பா? நாளைக்கு பார்க்கலாமா? நந்தினி?
Ma'am.
Yes பா?
மேம் அங்க நம்ம ஃபேஸ் வோல்டேஜ் எல்லாமே நம்ம கண்டுபிடிச்சிருந்தோம்ல மேம், ஏன் திரும்ப நம்ம லைனுக்கு மாத்தி லைன் கண்டுபிடிச்சிட்டோம்? ஸ்ட்ரைட்டா ஃபேஸ் வோல்டேஜ் வேல்யூவே அப்ளை பண்ணிருக்கலாம்ல மேம்.
ஓகே, அப்படியே கூட நீங்க பண்ணலாம். இங்க வந்து ஏன் லைன் வோல்டேஜ் கண்டுபிடிக்கிறோம் அப்படின்னா, இங்க வந்து ஃபேஸ் கரண்ட் நமக்கு வேணும். இங்க ஸ்டார் கனெக்ஷனா இருந்தனால ஃபேஸ் கரண்ட்டை கால்குலேட் பண்றதுனால நமக்கு வந்து நம்ம எல்லாத்தையுமே ஃபேஸ்ல ஃபர்ஸ்ட் கன்வெர்ட் பண்றோம். நீங்க லைன்ல இருக்கிறத ஃபேஸ் கன்வெர்ட் பண்றீங்க. ஃபேஸ்ல கன்வெர்ட் பண்ணீங்கன்னா என்ன ஃபார்முலா எடுத்துக்கணும்னா 3 V phase I phase cos phi எடுத்துக்கோங்க. சரியா? அப்ப நீங்க செகண்டரி சைடுல ஃபேஸ் கரண்ட் ஃபேஸ் வோல்டேஜ் கண்டுபிடிச்சிருக்கணும் இல்லீங்களா? அதை எடுத்துக்கோங்க. இப்ப வந்து 3 V phase என்ன செகண்டரி சைடுல
254.04.
ஓகே, I phase சேம் தான் 249.4 into 0.8. என்ன டிஃபரன்ஸ்னா இதையுமே எடுத்துக்கலாம். நீங்க நம்ம ஜெனரல் நம்ம வந்து ஸ்டார் டெல்டா கனெக்ஷன்ல ஜெனரல் பவர் வந்து √3 VL IL cos phi கொண்டு வந்திருப்போம். நீங்க சர்க்யூட் தியரியில பார்த்திருந்தீங்கன்னா தெரியும். சரிங்களா? இந்த ஃபார்முலாக்காக தான் நம்ம எல்லாத்தையும் கன்வெர்ட் பண்ணிருக்கோம். கன்வெர்ட் பண்ணதுல இருந்து திருப்பியும் இந்த IL-க்காக தான் நம்ம என்ன பண்ணிருக்கோம், கன்வெர்ட் பண்ணிருக்கோம். அதுல வந்து சப்ஸ்டிட்யூட் பண்ணிருக்கோம். நீங்க இல்லனா 3 * V phase I phase cos phi போடுங்க. அப்ப V phase I phase cos phi போட்டீங்கன்னா V phase கால்குலேட் பண்ணதை எடுத்துக்கணும். சரிங்களா? அப்பயுமே I phase நீங்க கண்டுபிடிக்கணும். சரியா? கரெக்ட்டா?
ஓகே மேம்.
V phase வந்து நீங்க you should calculate V phase as well as I phase also in the secondary side.
ஸ்டார் I phase and IL சேம் தானே மேம்?
ஆமா, நம்ம IL நமக்கு தெரியாதே. I2 தானே I2 கால்குலேட் பண்ணாதானே நமக்கு IL தெரியும்.
ஓகே மேம்.
அதுக்காக தானே கால்குலேட் பண்றோம். நீங்க எது வேணா எடுத்துக்கலாம். நம்ம ஆனா எப்படி இருந்தாலும் நம்ம கரண்ட் கால்குலேட் பண்ணி தான் பண்ண முடியும். சரிங்களா?
ஓகே மேம்.
வோல்டேஜ் அப்படியே எடுத்துட்டாலும் நீங்க கரண்ட கால்குலேட் பண்ணணும். சோ 3 ன்னு அப்படியே எடுத்துட்டீங்கன்னா V phase I phase வந்து சேமா இருக்கனால நம்ம அப்ளை பண்ணிடுறோம். சரியா? அதே டெல்டாவா இருந்ததுன்னா நமக்கு வந்து நம்ம கன்வெர்ட் பண்ணி தான் எடுக்கணும். டோட்டல் ஃபார்முலா இத எடுத்துட்டு இதுக்காக நம்ம கால்குலேட் பண்ணதை நம்ம சப்ஸ்டிட்யூட் பண்றோம். சரிங்களா? இப்போ நீங்க பேஸ்க்கு நீங்க கன்வெர்ட் பண்ணது வந்து I phase = IL அத நம்ம எடுத்துறோம். அதே டெல்டா இருந்ததுன்னா √3 * I phase
எஸ் மேம்.
சோ அப்ப அத சப்ஸ்டிட்யூட் பண்ணுவீங்க. கரெக்ட்டா?
எஸ் மேம்.
அப்ப √3 * I phase I phase = IL/√3. அப்பையும் நீங்க வந்து என்ன பண்ணனும், செகண்டரி கரண்ட கால்குலேட் பண்ணனும். சரிப்பா, நாளைக்கு பார்க்கலாமா?
ஓகே மேம்.
1 or 2 ப்ராப்ளம்ஸ் வந்து 3 ஃபேஸ்ல பார்த்துட்டு அந்த கனெக்ஷன்ஸ் என்னன்னு பார்த்துட்டு வைண்ட் அப் பண்ணிட்டு நான் ஜெனரேட்டர் ஸ்டார்ட் பண்ணிடுறேன். சரிங்களா?
ஓகே மேம்.
ஓகேப்பா. சரி, இது வரைக்கும் ஃபார்முலாஸ்லாம் எழுதிருக்கீங்களா? நான் எழுதிருந்ததை வேணா உங்களுக்கு சார் வழியா போஸ்ட் பண்றேன். சரிங்களா?
ஓகே மேம்.
ஏன்னா நீங்க நடுவுல வந்தாலும் ஃப்ரம் த பிகினிங்ல இருந்து எல்லாமே லிசன் பண்ணிட்டு இருக்கீங்க, ஃபாலோ பண்ணிட்டு இருக்கீங்க. அதனால கன்க்ளூட் பண்ணி அதனுடைய அந்த சாப்டர்ல என்னென்ன ஃபார்முலாஸ் நோட் பண்ணி வச்சுக்கோங்க. ஸோ இதுல வந்து நான் உங்களுக்கு அப்ஜெக்டிவ் டைப் வந்து கொஸ்டின்ஸ் நான் கொடுக்குறேன். இது அந்த டாபிக்கும் முடிஞ்சதுக்கு அப்புறம் நீங்க சாருக்கே வந்து ஆன்சரை வந்து அனுப்பிச்சு விட்டுருங்க. சரிங்களா?
ஓகே மேம்.
ஓகேப்பா. ஏன்னா இவங்க நந்தினி லெஃப்ட் ஆயிட்டாங்க போல இருக்கு. சரியா? இப்ப புதுசா ஆரம்பிச்சாலும் இல்ல இன்னொரு ப்ராப்ளம் கொடுத்தாலும் அவங்களுக்கு தெரியாது. ஓகேவா? 7:30 to 8:30 இனிமே வந்துருங்க.
மேம் நான் இருக்கேன் மேம்.
அதான் சாரி, மஞ்சு லெஃப்ட் ஆயிட்டாங்க.
ஓகே மேம்.
சரியா? இனிமே 7:30க்கு ஷார்ப்பா லைனுக்கு வந்துருங்கப்பா.
ம்.
ஓகேப்பா. ஓகே, பாய்.
தேங்க்யூ மேம்.
தேங்க்யூப்பா.